I want you to write Newton's laws. Do not look at anyone. Try writing it on your own for this scenario. This is M1, this is M2. M1 is bigger than M2 and friction exists. We're all writing Newton's force equations, yes? How many should there be?
4.
Why 4? I tend to start from the left side because why not? And I tend to go from left to right. If anybody else chose to go from right to left, that's totally okay. But I'm telling you my preference. And the second preference that I always have is I always consider the plane of the surface to be where my coordinates are. I will never make a coordinate system go this way if my plane goes that way, right? So that is just my preference. And the advantage of doing that is I don't have to worry about all of the forces I have. I only have to worry about just mg. And I know the force, the weight always points downwards, and I'll always have cosines and sines. So going off of that, I'm going to draw my coordinate system like this. This is my positive x, this is my positive y, right? And since this is a turning system, I'm going to use my bent coordinates, right? So my coordinates are going to go this way, and then they're going to bend around. So my positive x now will be pointing this way, and my positive y will be pointing that way. Yes, sir.
It's okay if you have basically have one.
That's totally okay. I'm just telling you my preference. I tend to do this. Again, if you do it the other way around, there is no harm in it, except every time where I have a minus, you'll get a plus. That's the only difference. Let's start with that assumption, that even the angles are not the same. And then friction exists. So now let's start talking about the number of forces in our cases. Well, one force I absolutely guaranteed know will be, which always acts on both masses. For mass 1, it will act downwards, m1g. For mass 2, it will act downwards, m2g. What is the other force on these particular objects that I guaranteed no exist? As long as an object is in contact with the surface, normal force always exists. So there could be a scenario that there could be a spot where I say, oh, ignore friction. But you can never ignore normal force as long as something sits on something, right? Whether it be a buoyant force acting because the water is there, or it could be a force acting on a table or a floor or something. So the normal force, green. And the normal force starts from this surface and goes up. I'm going to call this N2, and this starts from here, N1. And now friction exists in this scenario, in my situation. What direction should friction be? So here, think about it. Where would this system want to go? Why go that way down? Well, will it go M1? Will M1 go down or M2 go down? Why?
Because it weighs more.
It weighs more. So where does the system want to go naturally? Right? To the left. The system wants to go here, right? And friction does what? It always opposes where the system wants to go. Where would friction point?
Right.
Goes up that way, right? Well, where is M2 going?
Way.
Up. So where would friction point?
Down.
Everybody good? Are we missing any other forces? Yes, we're missing a very big one. Yes? Tension. We're missing the tension force. Okay, where will tension go? Tension is a what kind of a force? Is it a pull or a push? There are only two kinds. Is it a pull or a push? Good. So where will tension go?
Up.
For M1. What about for M2?
Up.
Exactly. Very good. So tension will go up this way. Let me call it T1. And tension will go up that way. Let me call it T2. Now, will T1 equal T2?
Better.
Yep. And will A1 equal A2? Acceleration in the A direction equals acceleration. So right now, let's ignore that fact. Let's write the equations first, and we'll worry about that when the time comes. Okay, so in this scenario, we will have mass 1. How many equations with mass 1?
2.
And we always start with sigma fx and sigma fy. I do that so that I know that I'm not missing anything. Sometimes people don't have to do all four, write them out, but I tend to do that because I've made enough mistakes to know that there is a probability I will make that mistake. So I just write sigma fx, sigma fy immediately as soon as I have this problem. And then I figure out, okay, well, I don't want to use it, and then I scribble it out, but it's always going to be there on my paper just because I don't want to mess up. Okay, and then I also do this, and that's my habit. You don't have to get into this habit, but that's what I do. I will always write mass 2 along with it, just so I know I'm not missing anything before I look at forces or anything. This is what I tend to do. So I will write for me mass 2, so I'm not missing it, sigma fx and sigma fy. Now I'm ready to look at the forces. Once I have my problem set up, now I'm ready to look at the forces. Okay, now let's look at mass 1. And I'm going to look at forces in the x direction. Well, I chose my system xy to match this one, correct? But M1G is not along my chosen coordinate. So what do I have to do? Reduce it to its components. So this is the 90 degrees. This one will be M1G cosine theta, and this will always be M1G sine theta. Everybody knows that trig, right? I don't have to repeat it. Good. So I'm looking at mass 1. What are all the forces acting in the x direction?
MG sine.
M1G sine theta, friction. What else? Tension. Now, how do I make this into an equation? Adding pluses and minuses. Very good. Okay, which ones are plus and which ones are minus? Now note how we do this stepwise. So M1G sine theta, what direction does that point?
Negative x down.
Okay, then friction will be?
You add that. Opposed here.
No, it's along my x.
That's what
Yeah.
It opposes
The motion. Yeah. Now that we're looking at forces, just look at the coordinates. Okay, if it opposes the coordinate or if it's along the x-axis. Okay, so don't look at motion anymore. Well, technically you should, but when you're looking at this, just look at whether it's opposite x or along x. Okay, tension, is it along or opposite? So it'll be plus. Now let's do this for Fy. What are the forces in Fy?
M1G cosine.
1 and normal. Which one's plus, which one's minus? Normal's plus and mg is minus. Great. And the same exact repetition for your M2. In this case, my M1G will be, you see where these arrows are pointing? Does everybody understand why these arrows point the way they do? Yes, head to tail rule from vector addition. Okay, so for F1x, for mass 2, what will we get? M2G sine of theta 2, and we will get friction, and we will get tension 2. Now it makes our life easier because immediately your eye goes to your x and y coordinates, plus and minuses. It should have it immediately. Which ones are plus? Oh, actually, what is the sign for M2G sine theta 2? Yes. Our coordinate system bent. Woohoo. And what is friction? And what is tension? See how easily you can confuse this? If you follow this recipe, the likelihood of us messing up goes exponentially down. These pluses and minuses are the biggest cause of mistakes. Okay, now what about Fy? What are the forces?
Yeah.
Okay, what else? Yep, anything else? That's it? Okay, is M2G cosine theta plus or minus? And is N2 plus or minus? Okay, now here's another cool part. What is sigma Fx1? And suppose we have an accelerated system. Plus or minus? Yes. Good. What about sigma Fy? 0. There is no acceleration in the y direction. What about sigma Fx2? Well, is it? What direction is it going? Up in negative x. So it will be minus M2A2. Do you see it? Do you see why choosing the coordinate system is so vitally important? Please don't mess that up. Okay, and then the last one will be 0. Done. Now you can worry about, putting numbers in, putting algebra in, tensions and all of that stuff, right? Are we good? Do we understand this? Excellent.